We're going to talk about organizing discrete data. And discrete is the key word there. Later on, we'll learn about organizing continuous data. And really, what we want to do is we want to take this discrete data that we have and put it in some type of useful form, so that way we have something useful to work with. And the first thing, one of the first ways we'll learn to organize discrete data is what's called a frequency distribution. And a frequency distribution is nothing more than a fancy T-chart. So frequency distribution. And its definition is basically lists each category of data and the number of occurrences for each category. So the easiest way to show you what a frequency distribution is just to do an example. So let's do that now. Example 1. And we're going to call this part A. A 6-sided die is rolled 20 times. And the following frequency distribution, and I kind of abbreviated frequency distribution there just to save some writing, is made. So basically what I'm doing here is I'm pretending that I'm rolling the dice 20 times, but I'm just going to make up the data as I go. So we'll start out with a T-chart like this. And here we'll label all the possible observations, or all the possible rolls in this case. So we can roll a 1, 2, 3, 4, 5, or a 6. Those are our only options. So when we roll the die, we can do over here a tally. So we'll roll it, and if it rolls a 1, then we do a tally mark here. If it rolls a 3, then we put a tally mark here for 3, and do that 20 times. So I'm just going to make up something here. We'll do 3 there, 5 for number 2, 3 gets rolled twice, 4 gets rolled 6 times, 5 is once, and 6 is 3 times. So far, pretty easy. And now we want to add another column on, and we'll call this one frequency. And it's basically converting these tallies into how many times it was rolled. So just putting the number to it. 3, 5, 2, 6, 1, and 3. And that's what a frequency distribution looks like. Now we're going to add something onto that here in this next part, here in part B. So first, before we get to part B, we want to give you another definition. So, and this definition is an extension that we're going to add on over here in a second. So this is called relative frequency. So all relative frequency is telling us is relative to the data that we have, meaning these 20 rolls here. How often did it occur? What percentage of time? So as we go, we know that when we roll a die that there's 1 in 6 chance of rolling any one of these numbers. But here, when we're talking about relative frequency, we're taking this sample that we have and we're just converting that into the probability that it was rolled. or the frequency that it was rolled here. So just a quick definition of this is the proportion, or you could say percent, of observations within a category and is found using this formula. And it's a pretty simple formula. So to find relative frequency, I'm going to abbreviate frequency here. That equals, relative frequency equals, so we're going to have a divided sign here, something on top and something on the bottom. On the top, you take the frequency, how many times that observation occurred. And in our case, how many times a 1 was rolled, and then a 2 was rolled, and so on. And then on the bottom, it's the sum of all frequencies. All right, there we go. So now let's do part B. Part B is to add a relative frequency column to part A. All right, so I'm going to come up here and I'm going to label this as A. And let's add another column on, and we'll say this is part B here. This is relative frequency. All right, so we do what the formula says. We take the frequency of, so let's start with number 1. We take the frequency, how many times a 1 was rolled, which was 3, and we divide that by the number of all the frequencies, which we know was 20. It was already told to us. It was told to us up here, but you can also add all these down and notice that equals 20. So to find the relative frequency of a number 1 being rolled, you take the frequency of a 1 that being rolled, which was 3, and you divide that by the total number of frequencies, which was 20. Which, if you put it as a decimal or a percent, it's 15% or 0.15. And that's what you do for all of these. So now you move on to number 2. Number 2 was rolled 5 times, and that's divided by the total number of rolls, which was 20. And that winds up being 0.25 or 25%. And keep going. Number 3 was rolled twice, so that goes on top, and that divided by the total number of rolls, 20. That's 10%. Number 4 was rolled 6 times, and that's divided by the total number of rolls, which is 20, and give you 30%. Number 5 was rolled once, that goes on top, divided by the total number, and that equals 5%, 0.05. And finally, 6 was rolled 3 times out of 20 rolls, so that gives you 15%. And this is in general how you'll find probabilities also. You take the total number that you want, and then you divide it by the total number of outcomes. And something to note here, if you, and we'll talk about this more later too, but it's good to have it in your head now. If you sum the relative frequencies, it will equal 1. Equals 1. And that will be the case from now on. So add these decimals here and it will equal 1, meaning 100%. This is where 100% of the observations occur. All right, so this is what a table looks like, talking about frequency distributions. Now we want to construct graphs to help aid this. So we'll just call this example 2 and construct a bar graph for the frequency and relative frequency. So you start off by just drawing a little chart like this. And down here on the bottom, we're going to have our die number, or the number rolled. So 1, 2, 3, 4, 5, and 6. And then up here, along the y-axis, this will be your frequency. And if you go back to our data, so that way we know what number we need to go up to and start at, our lowest number was 1, and it went up to 6. So typically, you want to go, when you're drawing your charts, you want to do one more extra number, so that way you have a little room here. So we want to do 1, 2, 3, 4, 5, 6, and 7. So I know the highest number was 6, so I went ahead and went up to 7. It just makes things a little easier to read in the long run. So you draw literally bars without them touching each other. So 1 was rolled 3 times. I'm looking back at our table. See if I can fit it here in the camera. So 1 was rolled 3 times. So I'm going to draw a bar graph just like this, up to 3. Then move over to 2. It was rolled 5 times. 3 was twice. 4 was 6. 5 was 1. 6 was 3. Simple as that. Now to do a relative frequency, the bottom will be the same. It's the die number. Except this time, we want relative frequency here. So those are going to be our proportions or our percentage. So come back to our graph, and our lowest is 0.05 and it goes up to 0.3. So what I'm going to do is I'm just going to go increments of 0.10 up to 0.40. So, and as you work these, you'll get the hang of this. It'd be a lot of writing to do 0.05 all the way up. So this is perfectly acceptable. So 10%, 20%, 30%, 40%. So 1 was rolled 15% of the time. 2 was 25. 3 was 10. 6 was 30%. Pardon my drawing. 5 is 5. And 6 is 15. So that's what a bar graph looks like. The only other thing we need to look at here is what a histogram looks like. And so, nothing better than just doing it by example. Construct a histogram for, let's just do the frequency. For frequency. And I guess up here in this example, I should have said construct a bar graph for the frequency and relative frequency from example 1. That would probably make it a little more sense to you. and frequency from example 1. And really you need to know how to do a frequency and a relative frequency histogram, but if I show you one, you know how to do the other. And I will leave that up to you to do as a little extra side work here when the video is over. So let's do a histogram. It starts out the same way, die number, and they're exactly the same except for one little difference. And we'll get to that when I get to drawing. And then along the axis here, this is the frequency. And I'm just going to label this 1 through 7 again. Now the only difference here for a histogram is that these bars are touching, and that's the only difference. So here for 1, it goes up to 3, and then 2 goes up to 5. So now instead of drawing separately like this, I'll just connect it to this other bar here. So this goes up to 5, just like that. And then now 3 goes up to 2. So this is really the only difference. Now this goes to 6. 5 goes up to 1, and 6 goes up to 3. All right, and I will leave you to do a relative frequency.